Now, when you go to 2, before at this point here of 2, surely they will give you somewhere here. Now, in this case here, you might find yourself having 3 of them, as to say 2 here, and then the 2 stops maybe here. They give you this distance, and they also give you that distance, just to separate the 2. So on the second one here, what do? You come on 2, you stop with it here. So now you will have, since you agree that this is positive, you will say positive 20 minus 35, which will be negative 15. Do you agree with that? No? Meaning your F2 will be negative 15. You apply it here again, you get your change in length 2. Do you agree with that? No? Before you go to change in length 3, you come, where was it? I was here, then you come at this part here. At this part here as change in length for 3. Change in length for 3. Now for the change in length for 3, you add this guy. And change in length for 4, you also add that guy there. You get them separately. Nah? That was just trying to give us an idea of the case where they give you the respective forces. Alright? They give you the respective forces. In case at the test you are lucky enough to get the respective forces, that will be straightforward. Do you agree, nah? But then the next thing is if they have just 2 forces on the edge, either extending or compressing, then you will say that those forces, whatever they will be the same, and the change in length will still be that. And if they are in parallel, you deal with that, then you go. Yes, ma'am.
So you say the first one, if I can't consider the 20.
You're going to consider the 20, yes.
And then the second one, I consider the whole thing 1 and 2.
You consider 1 and 2.
So should I go to 3? It's going to be 1, 2, and 3.
1, 2, and 3, and then this guy here will be just on this side here. But as I wrote this thing here, at this part here, when you cut on this part here, it might give a little bit of confusion because you might be tempted not to use this guy here. Because remember, as we were solving, if you cut and there is one pointing this side, remember if I'm cutting here and there is one pointing this side, we will not considering this guy first, right? So this guy here might bring some confusion because it was just a random thing that we're trying to look at now. But something concrete like a question, you're not gonna find yourself in a situation where you will ignore this guy, because at this point here I will ignore this guy, right? And at this point here again, looking at that side there, I'm still gonna ignore it. Do you agree with that? Huh? So just understand that it was just a question to try to get us in an idea of these forces that give you the forces, right? Like the specific forces. You can have something like that.
And then
yes.
Direction, does it matter?
Definitely. Now, when you put negative, if it's negative, after getting that change in length, you write extension. Positive, it's extension. And negative, it's compression. When you will be taking the total sum, you take the positive ones. If it's negative, you write as negative. You agree with that? Yeah? You keep positive and negative as well. So you can have something like that. So once you agree with that, next is what?
So wait.
Yes.
In terms of direction. So what if I consider this one negative and then the right positive?
No. You considering according to, if you cut at this part, you see if I'm pushing this side here, am I reducing this the length or extending? That's why I'm considering it as positive. Alright. Now, once we agree with this, then that's actually what is happening now with these two cases here. Now, once agreed with that, let's try to go through this example again quickly. Now we will see that if it's series, our relation of the stresses will come from the force now. Let me close and open the book. No one has the hard copy book. No hard copy book.